All right, so this is the review session for EGME 401, fall semester 2021 for midterm 1. All right, so I checked out the poll online, and it looks like the winners of the poll overwhelmingly was non-standard cash flows, right? And so I'm going to spend a good amount of time doing that. And then the next two were fairly even, although there was a narrow lead for for annual cash flow analysis, and so I want to make sure I get to that. And then number 3 was present worth. Okay, so let's go ahead and get started with non-standard cash flows. I guess specifically it's non-standard cash flow conversions. Okay. All right. And so this was, I think I agree with everyone here that this was probably one of the most trickiest parts of the kind of this first part of this class that we're doing for this midterm. Okay, because with non-standard cash flow conversions, you often have to do these in more than one step. And what I mean by that is that you have to apply more than one conversion, right? Because usually when we perform a conversion, we only have to do it once, right? And so let's say that we have some kind of future sum, okay? And then if we want to convert this to a present sum, we apply just a single conversion factor, right? P over F, I, and N, okay? And so that's usually all that we have to do. But for a non-standard one, we have to apply at least one more conversion factor. So usually it's only 2, okay? And then how you pick these 2 conversion factors, okay, I think can be a little bit tricky. But I think the trickiest thing, especially when you're working with, especially with arithmetic gradients and uniform series, is how do you choose the ends for each one, okay? Because choosing the ends can be tricky, right? And so for these, what I really recommend to people is that you really, take the time and draw out the cash flow diagrams for everything that you do. Okay. And so I'm going to do a simple example that kind of shows how to take an arithmetic gradient and a uniform series that may be non-standard and then convert them back to the present day. Okay. All right, and so let's take the following example. And so let's say that we have, the following cash flow diagram. Okay. Right, and so let's say that we have an 8-year horizon, and then let's say that we have the following cash flows, right? And so let's say that we have, maybe something like this, okay? Right. So let's say that we have a uniform series that that occurs right there, and let's say that we have a arithmetic gradient that appears on here, right? And starts appearing on year 4, okay? Right. And so each of these, each of the green, well, I'll do it without numbers for now. And so let's say each of the green has a value of A, okay, for arithmetic gradient, or sorry, for uniform series. And then the arithmetic gradient has a value of G, right? So the height of that arrow would be G, the height of the second arrow would be 2G, and the height of the third arrow would be 3G, okay? All right, and so I'm going to take this a couple ways. And so in the first step, what I'm going to do is I'm going to convert all of these cash flows to a present sum. Okay. And do that for both the uniform series and the arithmetic gradient. And then I'll convert, and then from there, I'll show you kind of the step-by-step process on how to convert this to a future sum. And in particular, I'm going to show you how to convert these to a future sum in year 8. Okay. Okay. All right, so let's work on the present sum first. Okay? And so you can see here we have two different cash flows, right? So we have the uniform series, and then we have the arithmetic gradient, okay? And so I'm going to take these kind of step by step, okay? And so let's do the uniform series first. Okay? Right? And so, the reason I'm doing this example is I think, this is the one that people typically get confused on. Okay. And so whenever you have any kind of recurring cash flows, whether it be a uniform series or an arithmetic gradient, what I always recommend to people is to first combine this, or, combine everything into one lump sum. Okay. And so that's what we're going to do here. And so even though we have a uniform series from between years 2 and 6, right? What I'm going to do is I'm going to first put this all together into one lump sum, because lump sums are a lot easier to work with conceptually than a recurring series. Okay? Right, so step one, let's lump together into one lump sum, or one single sum. Okay. Right, and so to do this, we need to convert this A, and we have two choices. We can either convert it from an A to an F, or from A to a P, okay? And so we can either use a P over A factor, okay? Or we can use an F over A factor. Okay. All right, but for this case, since we're going to a present sum, let's go ahead and move it back towards the origin. And so I'm going to use a P over A, right? All right, so the first step for this conversion is we're going to do A times a P over A factor. Okay. You can plug in the interest rate. I didn't give an interest rate for this problem because I want to focus just on how do you actually perform this conversion. But if this problem did give you an interest rate, you can go ahead and plug in for that. Okay. And then let's plug in the n, right? And so the n that you choose for a uniform series conversion is the amount of times that the cost recurs, right? And so you can see here that the cost is going to recur once, twice, 3 times, 4 times, 5 times, right? And so between years 2 and 6, we have five iterations, or 5 instances of that recurring cost. Okay. And so this is going to be n is equal to 5. Okay. Right. And so by performing this conversion, we're going to take all of these uniform series right here, all of these arrows, and it's going to go into one lump sum. Okay. And so the question is, where does that lump sum actually go? Right, so what I'm going to do, and I highly recommend that you do this too. Just especially when you're getting practice performing these non-standard conversions. Okay. Once you kind of get good at these, you can kind of do this step in your head, like you can kind of visualize it happening in your head. But until then, writing it out, I think, is the way to kind of really solidify that to get you kind of quick. Right? So let me go ahead and redraw our cash flow diagram. Okay. Okay. All right, and so before, what we had was a uniform series that occurs between years 2 and 6, right? And so what we did instead was we converted this to a present sum, okay? And so remember, when you convert a uniform series to a present sum, then the single arrow that shows up on the year before the uniform series starts, okay? Okay. Right, and so since our series here started on year 2, right? So if we look back at our diagram, our uniform series starts on year 2. To transform this back, we're going to put an arrow on year 1. So let's go to the next page, okay? And then we're going to have a single up arrow on year 1, okay? and it's going to be fairly large. And the value of that arrow is going to be A, P over A, I 5, right? And so, of course, right now you can't compute this because you don't have the numbers. But, if I did give you the interest rate and I gave you the A, then you can do just that, okay? All right, and so that's the value of that arrow, okay? But we're not done yet because, we've only just converted this uniform series, to one lump sum. But what we want to do is we want to convert this back into year 0 because that's the present sum, right? And so we need to perform one more conversion, okay? And that one more conversion is to take this lump sum, okay, and then put it back on year 0. Okay? And so let me go ahead and write this this entry again, right? And so right now we've done one conversion. So we have A, P over A, I 5, okay? And right now, what we have in this form right here is essentially a future sum, right? And so we have a single lump sum that occurs on year 1. And then, we just have to move that back for one more year, right? And so the conversion factor, in order to perform this conversion here, is to do P over F, I, and 1, okay? And so what that P over F does is that it moves that arrow from year 1 to year 0. Okay. Excuse me. Okay. And so these are the two conversions that you would have to do in order to move that non-standard uniform series back down to year 0. Okay. Okay. And so this is normally the time when I ask for questions, but when I do a review session, I realize no one's here. And so, okay, and so let's go ahead and move on, right? And so that's the first one, okay? And so next we're going to do the arithmetic gradients, okay? And I think this is the one which trips people up. And so, make sure you kind of pay attention to this one, replay it if you have to, okay? All right. And so this arithmetic gradient, this again is another form of a recurring cash flow, right? It's not the same as a uniform series because this gradient is increasing with time, but it is a cash flow type that occurs multiple times, okay? And so we're going to take the same approach that we did for the, uniform series, and that the first thing we're going to do is we're going to convert this into a single lump sum. Okay. All right. And so, again, we have multiple ways that we can do this. But, what I'm going to do is, since we want to move this eventually back to the present day, let's go ahead and convert it to a lump sum going to the left, right? Okay. And so since we're going to the left, the conversion factor that we want is P over G, right? And in fact, actually, if I open up the compound interest tables, I think there's not even an F over G. And so I think the only option that you have is if you want to convert a gradient to a single sum is to go with P over G, okay? Okay, and so, let's go ahead and do that, okay? And so the conversion that we want is G, P over G, I. And here's where things get tricky, right? And so you have to ask yourself, what do you set for the n, for the number of periods for this gradient? Okay. And so for a gradient, it's a little bit different than the uniform series. And so this is where the nuance comes in. Okay. So for the uniform series, what we did was we counted the number of arrows that we had, and then that was our n. Okay. Right, and so we're going to do the same. We're going to do something similar for G. And so we're going to count the number of arrows that we have. And so you can see here that we have 3 arrows, right? Okay. But then the n for this is actually going to be +1, right? And so you're going to take the number of arrows that you have, add 1 to it, and then that's going to be your n for the P over G conversion. Okay. Right. And so in this case, since we have 3 arrows, we're going to add 1 to that. Okay. And so the n for this is actually going to be 4, right? And so just to kind of be clear, so the way that we get this number is that we count the number of arrows, count number of gradient arrows, okay, then add 1. Okay. All right. And remember, the reason we add 1 is that the first year, right? And so the year actually before the gradient actually kicks in, that's always our blank year, right? And so it's the arithmetic gradient blank year, right? And so this year 3 right here is actually part of the arithmetic gradient because that's the blank year, okay? And so we have to count, it's basically like we're counting this 3 as well. And so if we count 3, the blank year, and then all the years with G, then we end up with 4, okay? All right, and so that's the first conversion that we have to do, okay? And so the next conversion that we have to do is to take this single sum and then convert it back into the present day, okay? But again, with this, you have to be a little bit careful, right? And so let me go ahead and, again, draw the cash flow diagram if you're not sure. Even if you are sure, it's always a good idea to draw the cash flow diagram just because it's, it can always help you. Okay. Okay. All right. And so originally we had our gradient here take place, we said it goes from 3 to 6, right? And so if we convert this to a P, the question is, what year do we actually put this on, right? And so the year that we actually put this on, right? And so remember, for the arithmetic gradient, we have the year where we actually start to see it increasing. We have the blank year right before that, okay? And so the year that you actually put the P value on is actually going to be the year before the blank year, right? And so remember, the blank year was year 3, okay? And so the arrow that we put in for this conversion is actually going to be on year 2, okay? Right? And so year 2, this is 2 years or 2 periods. I should say periods, not years, okay? 2 periods before you visually see the gradient. Okay. Right. So this is another tricky part to working with gradients and in cash flow conversions, right? Because you have to go kind of 2 years before you actually see it. Okay. Because then the year before you start seeing the gradient is the blank year, and then the present day value is actually a year before that. Okay. And so I think this is probably the mistake I saw the most in homework 2 when I was grading it. So, make sure you know how to do this. Okay. Okay. And so to convert this this gradient back to year 0, you can see that we have a single sum on year 2. Okay. And so to move it back, we just have to convert it back 2 more years. Okay? And so the conversion that we do, so let me go ahead and rewrite the conversion that we have so far. Okay. And so the conversion that we do in order to perform this this double hop is going to be P over F, okay, I, and then 2. Okay. And so those are the 2 conversions that you have to perform in order to get this back into year 0. Okay. All right. And so, I know the arithmetic gradient can be tricky, and so definitely, do some practice. I think the homework problem from homework 2 with the saving for the college degree, I think one's a really good one to practice, right? And so, if you want to practice, doing these conversions and making sure that you're good for the test, then that would be a good one to do. Okay. And I can, and I've already written the test. I actually just took it earlier this morning. I can say with confidence that if you can do that, if you really understand that problem with saving for the girls' college, then you're going to do just fine on that part of the exam. Okay. Okay. All right. And so now I did that part. I did these two parts kind of slow, right? And so let's do the next part of this problem where we convert it to a future sum. Okay. In year 8, and let's go just a little bit faster. All right, so now we're back to green. Okay, so we're going to convert uniform series to future sum in year 8. Okay. And so the ask for this, and so the problem is a little bit different, but the approach that we can take is basically the same. Okay. And so the first thing we're going to do is that, because we have a recurring type of cash flow, is that we can first convert this into a single lump sum. Okay. And just for the sake of practice, let me go the other way this time. So let me do an F over A factor. Okay. All right. And so what we have here is we're going to do an F over A factor, okay, with the interest rate I. The N in this case is still going to be the same as before, and so we're going to count the number of arrows. And so you can see here that we have 5 arrows, okay. And so we have 5, okay. Let me just draw the cash flow diagram for this really quick, just so you can see where it is. Okay. All right, and so when you convert a uniform series to a future sum, right, the arrow that you actually put is actually going to be at the same location as where the last arrow occurs, right? And so in this case, the last arrow was on year 6, okay? And so the single arrow that we put in is going to be on year 6. Okay. Right. And so this arrow right here, the value for it is going to be A, F over A, I, and 5. Okay. All right. And so next, we're going to move this over to, okay. And so if we're moving this to a future sum, then we have to do an F over P conversion, right? And so the overall conversion that we have to do is going to be A, right, F over A, I, 5, okay, and then F over P, I, and then 2. Okay. Right, and so that's the overall conversion that we have to perform. Okay. Right. And so this is not the only way. And so, if we're going to year 8, we can actually start the exact same way as we did for this one, right? And so for this one, we did a P over A conversion first, and then we did a P over F conversion after that. Okay. And so we could have started with the P over A conversion for this one. Okay. And so instead of F over A, we can have a P over A here. Okay. And so that'll put the arrow here instead, right? And so when we convert this to year 8, right, instead of 2 years, what we have here is instead 7 years. Okay. And so there's multiple ways that you can do this, right? And so there's not just one way. The only thing is that, just make sure you're staying organized, right? Make sure you get the right number of years for either one that you're going with, and to make sure you draw the cash flow diagram if you're not sure, because that can really help you to organize your work. Okay. Okay. And so that's the uniform series. So let's do the arithmetic gradient, and we'll do it really quickly. Okay. All right. And so first thing, we're gonna take that arithmetic gradient and put it into a lump sum. Okay. Unfortunately, there is no if you're using the compound interest table, there's no f over g factor, right? And so the only option that we have is p over g. Okay. Right. And so this is going to start exactly the same way that we did last time. Okay. I believe the n was 4, right? Okay. Right. And so just like before, this is going to put a single lump sum on year 2, right? Because that's 2 years before the increases start happening. Okay. But instead of moving this back to the present day, we're instead going to move this to the future. Okay. And we're going to move to the future 1, 2, 3, 4, 5, 6 years into the future. Okay. Right. And so we're going to apply f over p. Okay. I and 6 years. Okay. And so that's how you would perform that conversion, by moving your arithmetic gradient into a future sum on year 8. Okay. And so that's hopefully just to give you guys another look at these things. Okay. All right. And so that's how you do conversions of a recurring cash flow to a single lump sum. Okay. And so I'd say that's probably the most common way you can do this. But there is another form of a non-standard cash flow where you're kind of going the opposite, right? And so what if you want to take a single lump sum and you want to spread it across, as a recurring series, okay? If that single lump sum was in the present day, then there'd be no problems at all, okay? Because then you just have to perform a single conversion factor for that, right? Either a over p, or an a over f, okay? But if your single lump sum occurs sometime in the middle of your time domain, that can cause an issue. So let's do just a quick practice of that, okay? So let me go ahead and draw my cash flow diagram here. Okay. Right, and so let's say that we have a single lump sum, okay? And so let's say that we have a single lump sum in year 5, okay? Call this f. And what we want to do is we want to convert this f into a uniform series that spreads across all 8 years, okay? Okay. And so this is another common non-standard cash flow problem, right? Because I think the tempting thing here to do is that if we want to convert this f into a uniform series, the tempting thing is just to take this f and multiply by a over f, right? And so there is a column for this on the compound interest tables, okay? But the complicated thing here is that this f takes place in the middle of our time domain, right? And so it doesn't take place over the entire one. And so we can't just simply do this, okay? Because if we do that, and we basically perform just that one conversion, what that's going to do is that it's going to spread this f over a uniform series, but it's going to assume that the f is the final year in that series, right? And so, what it's going to look like instead is something like this in the yellow, okay? And so we're going to have a uniform series that only spreads across 5 years, okay? But we don't want this. We want a uniform series that spreads across the entire domain, okay? And so just like we did, for all the recurring ones, we're going to need to do multiple conversions here, okay? And so the first conversion that we can do is we can take this f and let's convert it back to year 0, okay? And so what we have here is F, P over F, I, and the N here is 5, okay? And so that's going to take our F and then put it back toward the origin, okay? And then what we can do from here, since this right here, this is a present sum, right? Or in other words, it's just a single lump sum of money in the present day. What we can do is we can spread this out now over all 8 years using an A over P factor. Okay. So what this does right here is it spreads it out. Over the 8 years, okay? All right, and so after we move this F back to year 0, then we apply an A over P. And so now we have all these little baby arrows, okay? All right, and so for the case where, you have a, a single lump sum, and then that, needs to be spread over the entire time, this is how you would do it in 2 steps, okay? And so this situation right here, this is very common if you're doing, let's say, an annual cash flow analysis, which we'll cover, in 5 minutes. Okay. And so you have an annual cash flow analysis, and then remember the goal of an annual cash flow analysis is to convert all of your cash flows into a uniform series that spreads over the entire domain. Okay. And so let's say that you have some kind of overhaul cost or maybe some salvage value that occurs in the middle of your time period, right? And you want to convert that to a uniform series. You have to do this with multiple conversions, using this method here. Okay. Okay. And so that overhaul cost first has to come back to the present day, and then from the present day, it can be spread among all the rest of the times. Okay. All right. And so I would say that kind of covers most of the most common non-standard cash flows that you'll see, and how to deal with them. Right. That's not to say that there's not more out there, but I would say this covers, at least for this class, about over 95% of what you should see. Okay. And it definitely will cover what you'll see on the exam as well. And so the thing with these non-standard cash flow conversions is that when you're studying these, I would really go through the trouble of drawing each cash flow diagram, what it looks like after each conversion, right? And so I know it's a pain. I know it takes up a lot of space and it takes a lot of time, and it's tempting to just kind of jump right to this conversion formula right here, right? But being able to visualize this, to see, to say that, after I perform this, this P over A conversion, or F over A conversion, to be able to see, what arrows get taken away from your cash flow diagram and where the new arrow goes, that's a crucial step for helping you determine what the next conversion should be, right? And so eventually, as you practice this more, you study it a lot more, you can start to kind of see it happening in your head. But I think when you're first starting out, I highly recommend you to, draw each of the different steps of the conversions with the cash flow diagrams, just so that you can very kind of visually see, what's happening when you perform each conversion, right? So basically exactly the same as we did here, okay? Because I think, after walking through this, hopefully you get the sense that, that doesn't seem that hard, right? And it shouldn't be, it shouldn't be, a difficult thing. But I think is that if you try to do too much of it in your head, you try to do too much at the same time, then it can be really tricky. And you either miss a conversion or you mislabel the amount of time that it takes, right? And so when you're studying, when you're practicing, really take the time, draw out the cash flow diagram, go through each step and say, what does this conversion do? Where does the new arrow go? Okay, and where does this new arrow have to go from here? Okay. And so that's non-standard cash flow. So hopefully that was useful to you. Okay. And so the next topic that I want to go over is annual cash flow analysis. Okay, because this was number 2 on the poll. Right. And so, if I had to summarize up what the important parts of annual cash flow analysis is that there's basically 2, right? And so there's number 1, what you have to be able to do is to look at a situation where you're comparing multiple alternatives and then compute the EUAW to find the best alternative. Okay. Right. And so this first point right here is very similar to what we did with present worth analysis. Okay. It's just, but except that for annual cash flow, it has, a number of advantages that we'll go over. Okay. And number 2, I'd say the other important takeaway for this unit here is to, learn how to organize loan payments. Okay. And the way that we did that was we learned how to write an amortization schedule. Okay. All right, and so to that end, I think there's not that much to explain with these topics. I think there's conceptually they're pretty easy. And so let me run through a quick example of both, just so that we get some additional practice. Okay, so let me actually find a good problem for the first one. Okay. All right, and so let's get some practice on point number 1 first, right? And so when you're performing economic comparisons, annual cash flow is just another technique that you can use. Okay. But the advantage that annual cash flow analysis has over present worth is that annual cash flow can be used on cases where the product lives differ. Okay. Okay. All right. And so, if you remember when we did present worth analysis, then when we ran into the situation where the product lives differ, we had to do a least common multiple approach, right? And so we basically had to extend the life of our product by buying replacements until we get a least common multiple between all the different options. Okay. But for annual cash flow, since the cash flow that we're getting is basically recurring over the period of time, what you can kind of think of this as is, this is kind of like an average over the product period, right? And so you don't actually have to do the least common multiple approach here. Okay. Right, and so you can just organize it, in terms of, in terms of what the whatever the product life is. Okay, given that you make this one key assumption. Okay, and so the big assumption here is that whatever product that you're buying, you're going to keep buying as replacements, and you're going to use it indefinitely. Okay. Okay, and so for an example, let me do a problem that I gave on a previous midterm. Okay, so this is from a couple years ago. Okay, and I think it illustrates the use of annual cash flow really well. Okay, all right, and so if I'm not going to write out the whole problem text just because it's kind of long, but if you read the problem text, there's nowhere in there where I say that you have to use annual cash flow analysis, right? Basically, the way that I presented this problem was that, I said that you have these two options, okay? And you have to determine which one is going to be the better option, right? And so it's kind of implied that you can use either present worth analysis or an annual cash flow, right? But for this case, annual cash flow is going to work out a little bit better or a little bit more convenient, just because the the product lives are going to differ. Okay. All right. And so in this example, we have maybe a shipping company or maybe a warehouse company, and they're considering the purchase of a new forklift. Okay. All right. And so we have two options. Okay. So we have forklift A and forklift B. Not very creative names, unfortunately, but they get the point across, right? Okay, so forklift A has an initial cost of $35,000. Okay. And an annual maintenance of $2,500. Okay. Right, and its useful life is 4 years. Okay. All right, forklift B. Forklift B has an initial cost of $42,500. Okay. The maintenance for this is $4,000 a year. Okay. And the useful life for this is 6 years. Okay. All right. And so assuming we have an interest rate of 9%, right? And assuming that these forklifts will be used indefinitely, okay? Let's determine which forklift is the better one for the company to buy, okay? Assuming that forklifts A and B do, they do relatively the same thing. And so performance-wise, they're not the same, okay? Or they are the same. Okay. And so the key part here that you should notice is that the product lives differ here, right? And so one's going to last for 4 years, the other one's going to last for 6 years, right? And so this is a great candidate for annual cash flow analysis because their product lives are different. Okay. Right. And so because of that, let's go ahead and compute the equivalent uniform annual worth. Okay. Okay. All right. So let's compute the EU AW for option A. Okay. Right. And so the EW is going to be minus 35,000. Okay. This 35,000 here is a present sum. And so to convert it to a uniform series, we need A over P, 9%. Okay. And we only have to do this over the life of the machine. And so the life of the machine is 4 years. Okay. And then we're going to do a minus 2,500. Okay. And the 2,500 is already in uniform series format. And so we don't need to convert that. Okay. Okay, and so the conversion factor here, if we look at the compound interest tables for 9%, okay, so we're going to look for A over P and 4 years. And what this conversion factor here is 0.3. 0.3087. Okay. And so if we input this into our calculator, for me, it's going to be math because my calculator is at home. Okay. And so we're going to do minus 35,000 times 0.3087 minus 2,500. Okay. And so this gives us EUAW of minus $13,304.50. Okay, and so that's the EUAW of A. Now let's do the EUAW of option B. Okay, and so this is going to be a minus 42,500, right? Again, this is going to be A over P, 9%. Okay, instead of 4, what we're going to use instead is 6, right? Because product 2, or forklift B, has a life of 6 years. Okay. And then we're going to subtract the maintenance cost. Right? So the maintenance cost is going to be $4,000 a year, okay, which we can just do straight up. All right. And so if we look up this conversion factor in the table, then we see that this conversion factor, this A over P, is 0.2229. Okay. And so we perform the arithmetic. And so we have a minus 42,500 times 0.2229 minus 4,000. Okay. And what we get is a minus 13,473. Oh, this is pretty close actually, and 25 cents. Okay. Right, so they're very close, but what you can see here is that the option A is slightly less negative, right? And so remember, when you're performing annual cash flow analysis or present worth analysis, you want to pick the option that has the highest either present worth or the highest EUAW. And for this case, it is option A. Okay, because it's the least negative cash flow. All right, and so that's a very simple example, but you can see that, if we try to do this problem with present worth analysis, we would have to extend the analysis up to 12 years, right? Because that's the least common multiple between 4 and 6. And so it's not the worst thing in the world, but it can take you some time, especially on an exam like one that's time limited. You want to make sure that you're most efficient with your time. And so if you can choose the method that is the most time efficient, that can give you the right result, that's usually the way to go, because then that gives you more time to work on other stuff. Okay. All right. And so that's a quick example for how you do annual cash flow analysis or find an EUAW. Okay. Now let's talk very briefly about how to organize payments on a loan. Okay. Because this was the other big part of the chapter, and I believe the last homework problem for you is this as well. Okay. And so the amortization tables right here, this is a way that's used to organize the payments on a loan. Okay. Right. And so the idea with the loan, remember, is that you are taking in a very large amount of money at the beginning, and then you're going to be paying off this loan using uniform payments over a certain period of time. Okay. Okay. All right. And so, there's two kind of main things that you need to do in these amortization tables, right? And so first thing you have to do is you have to determine your payment amount And the payment amount, the way that you do that is you do an A over P conversion. Okay. Right. And then number two here is that you build the table. And I'll go over just very briefly about how you build each column of the table, in this next example. Okay. All right, so let's do another example where we're going to be building an amortization table. Right? And so I'm not going to do the whole example just because there is kind of a lot to these problems. But this will just give you the idea of how to actually perform these computations. Okay. All right, and so in this example, let's say that you are remodeling your home. And so let's say that you're remodeling your kitchen and your bathroom. And the total cost of this renovation is going to be $165,000. Okay. Okay. All right. And so in this case, we're going to pay off this loan in 8 equal monthly payments. Okay. With an interest rate of 3%. All right, and so in this problem, I want you to compute first of all what the uniform payment amount is, and then we're going to build up the amortization table from there. Okay, and so first let's compute the payment amount. Okay, and so the payment amount, we're going to take our present sum, and so in this case, the present sum is the cost of the remodel, which is $165,000. Okay, and we're going to convert this to a uniform series. Okay, and so our interest rate is 3%, and then the number of periods is 8 in this case. Okay, and so let me go up to the compound interest tables for 3%. Scroll, scroll, scroll. Okay. All right, 3%, A over P, 8 years. And so this is going to be 0.1425. Okay. And so we perform that conversion. And so we have 165,000 times 0.1425. And we get a payment amount of $23,512.50. Okay. All right. And so that's how you compute the uniform payment amount. So you basically just have to do a conversion. Okay. And so the next step to these amortization schedule problems is to actually construct the table. Okay. All right. And so I'll go through the first row of the table for you. Okay. Oh, sorry. The first column is beginning balance. Okay. The next column is interest. Okay. The next column here is principal paid. Okay. And the last column here is ending balance. Right. And so normally, you would make this table for all of the payment periods that you have. Okay. And so for this problem, since there's 8 periods, we would have this table up to 8. Okay. And the first thing you should write here in the beginning balance is the, it's just the cost of whatever you're taking the loan out from. Okay. Because remember, the beginning balance, what that represents is how much money is left on your tab or how much money is left on the loan at the beginning of this pay period. Okay. Okay. And so from here, you kind of progress through, each of the different columns here and write in, what you should compute, right? All right, so let's start with the interest, right? And so the interest, remember, this is the amount extra that you have to pay just by taking out this loan, right? And so it's basically how the person who's giving out the money, it's how they're making money. Okay? And the way that you compute that is you take your interest rate, and which in this case is 3%, and then you multiply that by your beginning balance. Okay. Okay. And so for this first row, our beginning balance is 165,000. And so I'm going to take just 3% of that. And so I'm going to take 165,000 multiplied by 0.03. Okay. And I get an interest of 4,950. Okay. Right. And so that's what you get for the interest. Okay. Next, we have the principal paid. Okay. And so the principal paid, this is the amount of your payment that's actually going towards paying off your loan, right? Because we know that every month we're paying $23,512, right? And so remember when we talk about amortization schedules, a chunk of that money or a chunk of that payment is actually going to go towards paying off the interest, right? And so just whatever is left after you pay the interest, that's actually used to actually contribute towards your loan amount. Okay. And so the principal paid okay, this is going to be your uniform series amount A minus your interest. Okay. And so for this problem here, we have 23,512.5. Okay. And then we're going to subtract the interest amount. The interest amount is 4,950. Okay. And so for this first period, our principal paid is 18,562 and 50 cents. Okay. Right. And then lastly, what we have here is the ending balance, which is after you submitted your payment or after you make payment, this is how much is left on the loan, after that period. Okay. And so the ending balance the way that we compute that is we take our beginning balance. Okay. And we subtract the principal paid for that amount. Okay. Right. And so for this case, we started with a balance of 165,000. Okay. We're going to subtract our principal paid, which is 18,562 and 50 cents. And what we get is an ending balance of 146,437 and 50 cents. Okay. And so that's how much you have left on your loan after the first payment period. Okay. And then when you go to the next period, right, the beginning balance of period 2 is going to be whatever balance that you ended with on period 1. Okay. And so this is going to be 146,437.5. Okay. Right. And then you just repeat the same process kind of over and over again. So I know this one's really long because it's 8 years, and so it's a lot of calculations. But if this does show up on the exam, just be rest assured that it'll be a much less number of periods that you can complete it feasibly within the exam period. Okay. All right, and so that's all we got time for the review session, because I do have to hop into something else. And so hopefully this review session was useful to you. Okay. And of course, if you have any other questions, after this review session, or for anything else that you're studying, please don't be afraid to reach out. Okay. You can send me an email, and I'd be happy to respond. Okay. So best of luck with your studying, and I will see you guys next week.